Good evening, guys. How are you today? In today's tutorial series, we'll be looking at hypothesis testing. Hypothesis testing, that's what we'll be looking at today. So we quickly see how we can do hypothesis testing with SPSS. So we'll try to explain so that you can know the different type of t-test we have. We have three types. We have one sample t-test, we have two sample independent t-tests, and two sample paired t-tests. So these are the three analyses we're going to look at now. So we are starting with the one sample t-test. As you can see, this is what we are starting with, one sample t-test, and this is used to compare the mean of a sample with the population mean, or it is used to compare the mean of a sample with a specific value. Okay, so what we have on the screen is example of one sample t-test, because we have only one sample here, so it's going to be compared with a specific value that is already given. Okay, so let's do this example. The following data were recorded at the examination score of 20 students. We already have 20 students. The pass mark of the examination is 50, which also represents the population mix. Like I said, there's going to be a specific value given to you, which you are going to use to compare the population mean. Don't forget that t-test is to compare means of at least two population. Okay, so the research you want to know if there is any differences between the sample mean and the population mean, or the pass mark. So we have the hypothesis. We are not teaching statistics here. We have hypothesis, which say there is no significant difference between the sample mean and the population mean, while the other one, the alternative, say there is a significant difference between the sample mean and the population mean. So let's go there. All right, the data we just show us now, we have it in Excel. So let's move it to our SPSS. Our SPSS is up and down. So we know how to input from Excel. You just go to import data from Excel, import from Excel, and then you look at where you save the data. I save it on my desktop inside a new folder. So let me look for one sample t-test. One sample t-test is here. I've talked about how to export from Excel before, so I might not waste time on it. So I'm reading the first line as my variable name. Okay. So this is what we have. We have examination score. These are the examination score based on the example we gave. These are the examination score. Okay, 20 of them. We are going to compare with the pass mark 50. So it's not difficult. Don't need to go to variable view. Everything is set on the variable view. So we are not doing anything this side. Let's go to data view. So what do? Go to analysis. What we are about to do is one sample t-test. So you look for where you compare me, because we are comparing me of two. So compare me, and from the compare me you see one sample t-test. So click on it. You ask what the test variable. This is our test variable. You move it, and the text value is the pass mark, which is the 50. That's the mean. That's the population mean. So you run your analysis. Okay, and then this is the t-test. You can see it from here. T-test, one sample statistics. So we have examination score. There are 20 in number. The mean is 58.50. The standard deviation is 9.528. Okay, and this is the mean error here. So the test value, our test value is 50. You can see it from here. Our test value is 50, while our mean is 58. So we have run the analysis. Let's quickly interpret it and know if this is the test is significant. There's a decision rule. decision rule says that if the our our level of significance, which is 95 here, we're using 95%, which is 0.05. If our level of significance is less than our p-value, if our level of significance is less than p-value, that means we fail to reject null hypothesis. But if our p-value here, this is our p-value to take, if our p-value is less than our level of significance, which is 0.05, that means we reject a null hypothesis. So from what we have here now, we have 0.001, which is less than 0.05, which is our level of significance. Therefore, we fail to reject. We reject our null hypothesis if our p-value is less than our level of significance. We reject our null hypothesis. Otherwise, we fail to reject. So now let's check. We are rejecting the null hypothesis that says there is no significant difference. Okay, so we are accepting this one that says there is significant difference. So in the test we just did, there is a significant difference in the population mean and the sample mean. Why? Because the p-value is less than the level of significance, which is 0.05. Okay, that is the first one. Let's quickly look at the second one. The second one is two sample t-test. This one is two sample independent t-test, because the sample A does not depend on sample B. In these two sample independent t-tests, we will have what we call two samples, and we are going to compare their mean, and that's all. Don't forget the first one, we have only one sample, which we compare the mean with the population mean. But this one, we have two samples. We are going to compare the mean. Let's look at the case study. It says the table below shows the observed population index of air samples in two areas of a city, two different areas, area A and area B. Test the hypothesis that the mean population index are the same for the two areas. So the null hypothesis is that there is no significant difference in the two population index area, while authorities say there is significant difference in the mean population index for the two area. So let's import the data. Let's go back to SPSS. I have data for two sample independent two. Let's look for it. Two sample independent. It's still the same one. Two sample t-test. That's independent. Two sample t-test. So we open it. And you say, okay. So you see the area A and area B. This one at the middle, we don't need it. We can delete it. Let's go to edit and clear. Okay, to still do what we have. So this is data. These are the population mean. Population index. So we need to do what is called two sample independent, but we cannot do it with this arrangement. Okay, so we need to rearrange it. So what do we do? Let's create a column, insert variable. Okay, I will go back to variable view. I will call this one my group. Let me just call it group. Okay, this group, let me use capital G. Okay, this group is numeric, fine. Is decimal, fine. I need to give it a value. Okay, so let's do that now. We use one for area A, one for area A, add, and the two for area B, Okay. Uh, sorry, 2, not 1 again, 2. Uh, okay. So the decimal will be 0. Okay. So let's go back to the data view. We already have this one. So this is our A. We start calling it 1, 1, 1. Why we now move this one? Let's move it to, let's go and copy it or cut it. Paste it. Let me undo it. Undo it. Undo it. So let me copy it. Let me copy it. Copy. Paste. So this one now for me will be 2, 2, 2, 2, 2, 2, 2, 2. So we don't need this area again. We can clear it. Okay. So this is how you arrange data for two sample independent analysis. So once you have something like this, we have all the index. So this heading can change. The heading will now be something like a pollution index. Pollution. Pollution. Let me stop there. So you can go to the label and turn it to pollution index. Pollution index. Pollution index. So you go to analysis for you to do two sample independent. Go to compare means, go to two sample independent. So here now the pollution index is the text variable, while the grouping is your grouping variable. And you go to define it, go to define group, you have 1 for group 1. Because we say area A is 1, and for group 2 we say that area B we say is 2. So you define it and you continue. So you run the analysis. So if you look at this one, like this t-test, this group statistics. So this is two sample pollution index. We have group A and group B. They are 8 in number. This is their mean. This is the mean of the first one, 4.35. This is the mean of the second one, 3.34. So these are standard deviation and standard error. So independent sample t-test. You want to check for the independency now. You want to check if they are significantly different. Okay. So we also check our p-value. Here, these are p-value 1.6 to 1.62 is our p-value. When equal value is not assumed, and when it's assumed, they have the same thing. So we're going to check this. If it is less than the level of significance, and from what you are seeing now, 0.162 is greater than level of significance, which is 0.05. Automatically, we fail to reject non-hypothesis. So non-hypothesis is accepted, and it means that there is no significant difference between the area A, the pollution mean index of area A, and the mean index of area B. There's no significant difference. That's what this thing means. Okay. So let's look at the third one. The third one talking about paired sample mean. The difference between the first and second one is that in the first one, the two samples are independent, but in the second one, which is the paired sample mean, the two samples might not be, they are not independent, they are dependent. They are actually coming from the same source, from the same response. Okay, and you can see it now. We have a student that let me go back to the question. He said, is there a difference in marks following a teaching convention? The marks for a group of students before and after a teaching intervention are recorded. The marks. So these are the students that they give a test before they teach them, and this is the pre-test. Why after they taught them, they give them, this is before the mark, this is before they were taught with the new method, this is the after. So it is still the same 1 to 20 students that answer these two questions. So they are dependent, they are paired, because the two respondents belong to one person but at the same, at different time. Okay, so that's why it is called paired sampling, but it's a two groups, but they are paired, so they automatically uh, dependent. Okay, so let's quickly do that one. What do we do? You go back to your SPSS. Let's go and import the data for that one. Go to Excel. This data is just for example. I already have it. Paired one. Open. Yeah. So we have it here. If you look at the last part, this is now is total. So we don't need this last part. This is total. This is total of all of them. So we don't need this one. We remove it. Go to edit and go to clear. Okay. So this is what we have. We have before mark. We have after marks for these students, and these are their differences. If you are calculating manually, you use the differences. Okay. So what do we do? You go to analysis. You go to compare me, and you go to peer sample t-test. So to do the peer sample t-test, you move the first one as the first variable and the second one after as the second variable. And that is all. You click OK. So you have run the peer sample test, that's the t-test 2, which you can see their mean before 18.4, after the test, after the teaching 20.4. So it's just difference in these two mean. They are 2020 students, the same student 20. Okay, so here we tell you that they are related, they are dependent. The correlation between them is 0.717. Show you that the correlation is high. The correlation is high. Show that they are dependent. Okay, that's just this one is telling you. Let's go further to the peer sample t-test, where you will now go and check the level of significance. We'll go and check the p-value. 0.004 is the p-value, which is less than 0.05, which is the level of significance. So it's telling you that this test is significant. We are rejecting the null hypothesis. Okay, so there is a significant difference between the mean of the mark before the teaching and after. Shows that the teaching also affects the knowledge of the students. Okay, so these are the three types of t-tests. One sample t-test, two sample independent t-test, and a two sample peer t-test. I believe you enjoyed the class. If you are not following me, kindly follow me at Triple E Academy 24, so that as we are dropping other videos, you will also be getting notification and then you can enjoy the video. Thank you very much, and God bless you.